I'm Steve Banwart. I'm director of the Global Food and Environment Institute, and am hosting the meeting today together with my colleagues Laura Carter and Sarah Dennis at the University of Leeds. And we have colleagues from a number of organizations around the UK, China, and USA. We're addressing this topic for a UN Food Systems Summit dialogue in September. The UN will host a Food Systems Summit, and they are supporting and sponsoring a number of these working meetings through the end of this month to provide background evidence to support the program of the UN Food Summit. The aim of the meeting today is to share knowledge on the feasibility and risks of using organic fertilizer in agriculture production through adoption of a circular economy approach. We're structuring the working meeting today around three key themes: current policy frameworks and future policy drivers, technical adaptations and waste recovery in the use of resources, and potential risks and mitigation measures. I have a couple of housekeeping points just for participants. You'll see in the chat line a link to help you change your name if needed, so that when we go into breakout sessions, participants can see each other's full name and the organization that you're in. The other thing is that in order to keep to time, we won't have extensive question and answer sessions during the talks. Colleagues, participants are encouraged to put your questions into the chat of the Zoom call, and we will share these questions after the meeting, and we'll try to provide answers. Let's go to the next slide. We will have 4 brief flash talks just to introduce the topic and the themes. And then the main part of the meeting will be a 1-hour discussion in breakout discussion groups. We'll have 3 groups, and we'll come back together after those discussions for key points to be reported back to the group. And then we'll have my colleague Laura Carter will lay out what the outcomes are from the meeting today, but principally we will produce a written report for the UN Food Summit Organizing Committee to bring into their planning for the Food Summit. And we plan to produce an authoritative position paper drawing on all participants as co-authors for that. Let's go to the next slide. I'll go ahead and start. Next slide, please. I'm going to give a quick overview, and I'm going to just mention this topic of the Global Climate Food Sanitation Challenge, and it addresses 3 of the Sustainable Development Goals. Others are touched upon, but principally SDG 2, Zero Hunger, SDG 6, Clean Water and Sanitation, and SDG 13, Climate Action. I'm going to give a quick overview together with my co-authors that are listed on this slide. This dialogue is being co-organized by the Global Food and Environment Institute and also the China United Kingdom Critical Zone Observatory program. The list of organizations on my slide of partners are the partners of one specific project, and that project is around peri-urban agriculture and the use of organic fertilizers from urban sanitation streams and from agricultural manure to be applied particularly in peri-urban agricultural regions and to help displace the demand for mineral fertilizer. And our study area is specifically in China, in Zhejiang province near Ningbo city. I'll go to the next slide. The challenge around the climate crisis and the food supply, summarized here in a very simple summary of the terrestrial carbon flux balance as reported in the 5th climate change assessment report of the IPCC is that nature is supplying about 4.3 megatons per year of carbon through net photosynthesis minus the respiration of carbon back to the atmosphere. So nature is fixing carbon through photosynthesis. And of course, the problem is anthropogenic emissions. Human needs are, on the demand side, are requiring much more carbon, particularly from fossil fuel combustion. And we are returning to the atmosphere about twice as much as what nature is fixing. And most of this is through fossil fuel combustion, the number of 7.8 megatons per year of carbon, but also land use change, particularly deforestation and other loss of virgin vegetation, particularly for agricultural land, is a major contribution. Next slide, please. The diagram on the left is just representing the greenhouse gas emissions projected by year under different IPCC scenarios. The units of the vertical axis are slightly different. These are now in tons of CO2 per year. The previous slide was as carbon. This is as CO2. And it is demonstrating that in order to maintain future warming below the 2-degree handrail, even better if it could be 1.5-degree handrail as laid out in the Paris Accord, means that we really need to be reducing anthropogenic greenhouse gas emissions from now going forward. And that this is going to require not only a cut in emissions, but currently probably also a significant capture of CO2 and removal of CO2 from the atmosphere. And one example of an area that is being proposed is through carbon sequestration in soil through agricultural management. And the global food systems emissions in the UN Environment Program report, recently summarized by an excellent paper by Kripa et al. In Nature Food, and further contribution on some of the technology involved for solutions going forward by Horton et al. Recently in Nature Plants, is about a third of these human anthropogenic emissions are coming from the food system. Most of those are coming from agriculture production. Of that, about 30% of agriculture is from the land use change and 40% is from a production emissions, of which a significant component is coming from a mineral fertilizer production through the Haber-Bosch process. And we talk about this potential for CO2 capture through carbon sequestration in soil. Next slide, please. The link then to the food supply, I've summarized here with slightly different units for the terrestrial flux balance for nitrogen. And I've done this as grams of nitrogen per person per day. So it's a daily per capita flows of nitrogen. And again, we have the supply side where we have nature fixing nitrogen and we have terrestrial denitrification, but also fixing nitrogen is cultivation of legume crops and the industrial fixation of atmospheric nitrogen through mineral fertilizer production. And of course, what we understand is that the industrial fixation and cultivation for agriculture, that these two routes of fixing nitrogen are far dominant over the natural biological fixation before the Industrial Revolution. And then human dietary consumption is much less. It's around 11 grams of nitrogen as protein per consumption per day. And it's more than the recommended healthy amount. And there is this gap between the amount of nitrogen which is fixed for agriculture and the amount that we take in dietary intake. And there are many reasons for that. One, of course, is that we don't eat all of the biomass that is produced in agriculture, but agriculture also loses a lot of nitrogen as reactive nitrogen species, greenhouse gas, nitrous oxide to atmosphere, nitrate into water. And then the work of Jeremy Guest and colleagues, Jeremy's with us today, around looking at the availability of nitrogen recovery from sanitation waste streams as a potential source of nitrogen for return back into agricultural applications. So there is also this potential to recover this nitrogen resource, but also carbon and phosphorus, and also potassium, particularly from food processing waste streams. And then the other big source of nitrogen back to the atmosphere is fossil fuel combustion. So just a final slide before we move on to the next speaker, please. Tu Young Guan, who will be speaking next, he has pointed out in a 2017 paper, conceptualized this idea of a circular economy between consumption of resources focused in cities and the rapidly urbanizing global population on one hand. And then we know that we have a rapidly urbanizing population, particularly in low and middle income countries, and particularly in the global South, but where there is an opportunity for sanitation improvements for these urban populations to include resource recovery and to return this back, for example, reuse of gray water, but returning carbon, nitrogen, phosphorus, and potassium back into potentially to agricultural applications. It doesn't close the energy demand completely, but it can be a contribution potentially to net zero food production. And then, of course, using that agriculture production in a circular economy to move food back into the cities. So I'm going to stop there. That's a brief introduction to the topic today, and we'll move directly on to our next speaker.
Yes, Steve, can you reverse that slide? I will particularly focus using this slide to frame my speech. So thank you, Steve, for your invitation, and hello, everybody. I think this, Steve already alluded about the topic I will be touched on is how can we make the agricultural production system of the food system sustainable in the era of rapid urbanization. And we are addressing this issue from Chinese perspective, but it has international implications. So in China, we have seen in the last couple of decades a rapid soil acidification and or loss of soil organic matter because of the overuse, often overuse or intensive and overuse of chemical fertilizers, particularly nitrogen, which leads to the soil acidification and also the degradation of soil organic matter without proper return of the organic residue back into the food production system. So this soil acidification actually accelerates the emission of carbon, not only the organic fraction, but also the inorganic fraction, carbon dioxide loss from the soil. So to reverse this process, in China, the policy driver is that we must freeze the increase of chemical fertilizers from last year. And to do that, we must increase the use of organic fertilizers. And in our joint project, supported by the National Science Foundation of China and also the Newton Fund from UK side, we have been looking at the possibility and the feasibility of using organic waste from urban waste system and also from intensive animal farming system. How can we make this recycling sustainable and also safely? Because we know that in the consumption process, the organic manure or the organic waste are also contaminated by heavy metals and also emerging contaminants such as personal care products and pharmaceuticals. And in this case, particularly antibiotic resistant genes. So we think that we have to make this sustainable recycling of urban and agricultural waste, but we have to do it by removing or by mitigating the risk factors from this waste stream. One example we have been working on is to turn organic manure into biochar by producing biochar from organic manure or from urban, for example, sewage sludge. We can remove the pathogens from this organic waste, but also to a large extent, we destroy these organic chemicals by heating at 500 degrees or sometimes 600 degrees. And through our experiments in the laboratory, microcosm, and also in the field plot, we can now demonstrate the safe and sustainable recycling of urban and animal waste is possible, and it is also beneficial in terms of carbon sequestration in the soil, because we know that biochar is more recalcitrant in the soil, and they can be stored in the soil for much longer period. And also biochar can improve the soil structure. For example, the soil aeration, and also improve the microbial diversity and activity. And in a way, also improve the nutrient cycling and the dynamic in the soil, so that improve the bioavailability of these nutrients for crop production. So we think that in a global sustainable food system, soil is playing a central role. And to make the soil as a critical component of the global food system, the recycling of organic waste from both agriculture and urban system is critical. And currently, some technologies are already available. But in the future, we think that we should not only just looking at the technological side, but also looking at the economic side of this recycling or this urban-rural symbiosis. So for example, we needed to look at the budget of greenhouse gas emission during this recycling process, and also the nutrient budget in this whole process. And we can also calculate the ecological footprint in terms of carbon, nitrogen, water. And even we are thinking about the microbial footprint of the global food system. And my colleagues, both at the Institute of Urban Environment, but also in the Research Center for Ecosystem, Eco-Environmental Sciences, we are working in a big team, a multidisciplinary team, to look at the technical side, the scientific side, but also the economic side of the circular economy for sustainable food system. And we think that we should focus 2 points. One is the legacy effect. By saying that when we change the practices, and there is always a lag phase for us to observe the impacts on the soil ecosystem. So we must think ahead of time when we change our management practices. And the second keyword is about the cascading effect. Anything we intervene along the soil, food, environment, health nexus, there will be translated, or even in some cases can be amplified along this chain of reaction. So we must keep in mind when we adopt a new management system, we should consider the legacy effect and the cascading effect so that we can make sure that our food system is sustainable in longer term. And in particularly with the rapid urbanization, we are now having more than 60% of the people in China is living in cities. And we have to support this urban population with sustainable food system. And we are talking about the scenarios in China, but it is also, I think, applicable to many developed and developing countries. And I will stop here, and I welcome questions or comments. Thank you, Steve.
Great, thank you, Yongguan. We'll move directly to our next speaker.
All right, thank you very much for the opportunity to be here. So I'll briefly introduce go into a little more depth maybe about the resource recovery from human waste in particular. I think these are important topics, and we're excited to talk a little bit more about this. So if we can go to the next slide. So in essence, like we focus a lot on resource recovery from human waste, but bodily waste. And one reason we do this is because people were basically at steady state, which means the nutrients, in particular nitrogen, phosphorus, and potassium that we take in, we excrete. So our bodies are not accumulating nitrogen or phosphorus or potassium, and we lose potassium through some other fluids like sweat. But nitrogen, phosphorus, basically it's all in our urine and fecal matter. And so through resource recovery, we can potentially access these nutrients again. Our bodies are better at metabolizing carbon, so there's less of that coming out, but we take in a lot of organic carbon, and so that's there as well. We can go to I'll mention one other thing on this slide, just that the amount that we excrete is largely dependent on our diets because we're at steady state. So if we know people's diets, we can have a sense for what they're excreting. And we can go to the next slide. But these are complex systems, as we're hearing. And so when we think about recovering resources from human bodily waste, we're trying to think about whether we're talking about urban populations or rural or along the continuum, the connection with agriculture and the characteristics of the local soils and agricultural needs, sanitation, because that is our primary concern, is protecting public health and protecting environmental health. We can think about the susceptibility of receiving environments or the communities in which we're executing resource recovery, and making sure that we're improving equity and well-being with any intervention that we're pursuing. But what I mean to show with this figure is just that these are complex systems. They are dynamic, they are highly contextual. It depends on the location in which you are, the nature of these relationships. And that's something we always want to understand when we talk about resource recovery. We can go to the next slide. And a couple factors that we like to think about, I just want to share in advance of the discussions we're going to have. First is thinking about in a given location, will resource recovery sanitation significantly increase access to fertilizers and or energy? And in the context of sanitation, a lot of times in resource recovery, we might hear that it's not enough. So people often focus on the target nitrogen, phosphorus, potassium needs of crops. And in most locations, we're not adding as much as would be recommended to maximize yields of crops. And if you look at recovering resources from human bodily waste, it won't get you to that level necessarily in many contexts that you're fertilizing enough or all the way at the level to maximize yields. But that's not that shouldn't be the only concern from our perspective. In a lot of places, you can dramatically increase access even over projected fertilizer access 10, 15 years from now, you could more than double the access to fertilizers that people could have through resource recovery. And we think that's meaningful. So increasing access to fertilizer. We can go, thank you. We also think about co-location. So where is the supply, where are people, and where's the demand, where are the crops? And we can look at spatial scales, and in a given population center, if we're talking about urban environments, we then look at people's diet, and then we look where they're located, where the agriculture is located. And if we were to apply the recommended fertilizer dosing to maximize yields, how far out from the urban population, for example, would we have to go to use up those nutrients beneficially? And we could do that across cities. And in particular in China, there's a lot of opportunity because agriculture is often not far away from the city. We can go to the next slide. And then we also have to think about soil context. And so in this way, we look at the products that we can recover from human bodily waste, but also the soil context and which products would be beneficial to the soil quality and crop yields to avoid salination, to avoid pushing pH in the wrong direction, things like that. But organic fertilizers in particular, like we see, they can go lots of places without detrimental impacts. And then lastly, thinking more broadly about the benefits of doing this through ecosystem services. So by increasing soil quality, for example, which we've heard several times now, there can be lots of these cascading effects for ecosystem services that we should be thinking about and potentially quantifying to further understand the benefits. And we can go to the last slide here. And so this is a paper that's like in revision, so hopefully you'll all see it soon, but I just wanted to share it because I had a map on hand, for example, for China. But what we did here was grid cell by grid cell across countries, over 100 countries. We looked at where was the nutrient supply and what is the nutrient demand in that grid cell. And then if it's purple or blue, it basically means that you could use up all the nutrients in that grid cell provided by people on agriculture in that same grid cell. And if it's orange, it means it's like there's more people basically, or very little nutrient demand. And if it's the light beige, it means there's either a lot of people or like a city, or there's no real nutrient demand. So desert or some other condition like that. There's no real agriculture. And so this is my last graphic here. What we do is we're creating these nutrient saturation profiles across countries, across locations, any region you like, to understand if we're basically to the left of this purple line, it means that you can use nutrients in the grid cell in which they're generated. You can reuse nutrients locally. If you're to the right of this purple line, it means you start to need to think about concentrating the nutrients and transporting them farther away to agriculture. And we see these very distinct profiles in a lot of countries, but in particular, you can see China on there as an example, India, whereas United States is way down and to the right. And what this suggests, this is just helping us think about how we recover nutrients and what form might be beneficial. But for example, in China and a lot of other contexts, the organic fertilizers or a bulkier nutrient recovery still has a lot of potential because of the proximity between and the co-location between nutrient supply, people, and nutrient demand, agriculture. Whereas the technologies developed in a lot of other countries and that are pushed in like the United States, for example, necessitate concentrating the nutrients into something like struvite because they have to be transported hundreds of kilometers. And that's not the case in places like, for example, China. So I'll stop there. Thank you for the opportunity.
We'll move on to our next speaker.
Thanks, Steve. So before we begin, I thought it would be useful to start with a definition of risk. So broadly, when we think about risk, we are talking about the probability and consequences of an unwanted accident. But for our discussions today, I thought it would be useful if we had a more focused definition around risk. So when we're thinking about sustainable agriculture, what is the risk associated with this? So I've proposed the following. So risk can be defined by the impact of agricultural practices, impact of sustainable agricultural practices on ecosystem and human health following the reuse of resources. And I thought it would perhaps be a nice way to start the group discussions that we're moving on to next by defining what you as an individual consider to be a risk in the context of sustainable agricultural practices. And it's important when we're thinking about the risk here, our focus is coming at it from the presence of contaminants in the soil plant system. And it's the interaction of the environment with these contaminants that presents this long-term legacy risk that was previously introduced. So thinking about the hazards that are present, first of all, inorganic compounds. So these are the nutrients, the heavy metals that we need to consider. And organic compounds, this includes things like PCBs, PAHs, and they have the potential to enter our agricultural systems inadvertently. And it's also been touched upon briefly as well, but a group of organic contaminants which are receiving increasing international attention are collectively known as emerging contaminants. And here the focus is on pharmaceuticals from human and veterinary origin, personal care products, nanomaterials and plastics, for example. And then lastly, we have to consider the presence of pathogens. So this includes various bacteria, viruses, and protozoa. And I won't spend too long on this slide because we've introduced the various ways in which we can think about sustainable agricultural practices in the environment. But I think this slide really highlights the connectivity that we have to deal with when we're considering the risk of these practices. So you can see the complexity of the situation when you're using organic fertilizers as a soil amendment and wastewater as a source of irrigation. And it's these practices that can introduce these contaminants into the environment. Now, the World Health Organization has recently stated that pollution and environmental degradation knows no borders. I think this is really important because it shows that contaminants can move through the air, they can move through water, soil, and food to anywhere in the world. And indeed, pollutants in the environment or contaminants in agroecosystems are a global problem. But to focus our discussion slightly for today, we're going to be thinking about scenarios in UK and China specifically. However, this doesn't mean to say that our discussions and our outputs are not relevant to other countries where circular economy principles are adopted. So moving on to consider risk. Once we've defined what we mean by risk, what are the risks are we considering? So I've just listed some ideas here around potential impacts on human and ecosystem health, and they were nicely touched upon in the flash talk by Professor Yongguan Zhu. But just to get you thinking about the risks, we're here thinking about the presence of contaminants in the soil. And this means that they can be taken up into non-target organisms. So the organisms could be plants or they could be invertebrates. And then there's the potential for the contaminants to accumulate through the food chain. And because these chemicals are bioactive, they have the potential to elicit toxic effects in the organisms and on soil health as well. We also have to consider how these practices contribute to the global spread of antimicrobial resistance. And this is especially true for antibiotics and how they've been recognized as playing a large role in the proliferation of resistance. And lastly, contaminants in sludge and wastewater can pose a risk to human health if they're transferred to the food crops that are grown in sludge treated or wastewater irrigated soils. So the breakout discussion groups that we're going to move to next are really a chance to explore your viewpoints when we're considering the risks in the context of sustainable agricultural systems. But it might be important when you're thinking about the risks to discuss whether the scenarios which have demonstrated effects are environmentally relevant, whether you need to think about combined stressor effects. So thinking about the presence of mixtures, for example, in the environment. And then lastly, thinking about mitigation measures. So we all know that the use of organic fertilizers and sustainable agricultural practices brings many benefits, and some of these have been touched upon. But the reason why we wanted to frame this discussion around risk is because without this baseline understanding of any potential hazards, we cannot work towards developing mitigation measures to ensure that these practices are carried out in a safe and sustainable manner. So some potential mitigation options could include, for example, advancing wastewater treatment technologies, and this would reduce or limit the amount of contamination that's being released into the environment in the first place. There's also the drive from pharmaceutical companies, so thinking about emerging contaminants in particular, to develop benign by design or follow greener drug development principles. So this is where you're taking into account the fate and the risk of the chemical in the drug development process to create a better drug when it enters the environment in terms of its persistence. It can be readily degradable, for example. And last week I was at a CTAC session. I think it's important to bring up one of the discussion points that was one of the topics that we focused on. And it was thinking about mitigation, but accounting for regional challenges. So this is where, for example, you have limited sewage connectivity. Perhaps improving wastewater treatment plants is not the answer in terms of reducing the risk from sustainable agricultural, from the use of these resources in sustainable agricultural systems. If there's no sewage connectivity in place, then putting in advanced wastewater treatment technologies is not the answer. So potentially here we need to think about nature-based solutions, so using wetlands or aquatic macrophytes, for example. So I'll leave it there, but hopefully this has provided a quick overview as to when we need to think about risk and mitigation when we're considering sustainable agricultural practices. And I look forward to discussing this with you in the breakout groups. So that's what we're going to move on to next. So in the breakout groups, we're going to focus our discussion on the 3 key themes that we've just had flash talks on. So these are current policy frameworks and future policy drivers, technical adaptations in waste recovery and use of resources, and then potential risks and mitigation measures that arise from using sustainable agricultural practices. So the breakout groups will be led by Professor Tim Daniel, Dr. Xiaohui Chen, and Professor Hongyang Guo. And we'll have a note taker in each of these discussion groups to add discussion points to a Padlet wall. And in terms of the notes that we're looking for key take-home messages that we can synthesize together at the end, and more free text to be added at the bottom of the Padlet sheet. So each group will discuss these 3 themes. So you'll stay in the same group and you'll take it in turns to discuss each of these 3 themes. And it might be helpful that when you move on to the next discussion point that you think about creating that bullet point or that key take home message that synthesizes your thoughts on the discussion that you've just had. So the discussions will not be recorded. So it's under Chatham House rules. So please speak freely and in confidence. We want as many opinions to be put forward as possible. And we want this to be a friendly and open discussion forum. So you've all been assigned to a breakout room. And as I said, we'll remain in these breakout groups for the discussion period. And then we're going to come back together for a summary of the key findings and key messages that you're drawing out in your discussions. So please, can we send everyone to their discussion groups now? And if you have any problems, then please leave the breakout room and then you can come back to this main area and then we'll put you back into the breakout groups where you should be. So hopefully we can do that now. Okay, so hello everyone and welcome back after your breakout discussion groups. So I'd just like to introduce Professor Barbara Evans, who is a leader in urban sanitation with a particular interest in the Global South. So Barbara, you'd be welcome to expand upon your interest in this topic before you lead the summary of the key take-home messages from the discussion groups. Thank you.
Great, thanks very much. I had quite a difficult job because I was hoping to be able to pull some themes from the working groups, but obviously it's a big topic. So I was thinking about this a little bit back to front and listening to our colleagues who opened the session this morning. And, you know, whenever I hear Steve or, you know, any of you talking about this topic, I think this is ridiculous. You know, this is all so obvious. Why is it not happening? And I was thinking about it the other way around. I was going to say to you all, just imagine if we were actually sitting here saying, all right, guys, what we'd like to do is propose a revolutionary new system where we take human waste, we're going to add a load of plastics and pharmaceuticals to it. We're going to transport it using a very inefficient, costly system to a place where we're going to remove the nutrients and dispose of them at really high cost, resulting in a whole load of additional carbon emissions. Then we're going to discharge the remaining liquid fraction into water bodies, either still completely full of pathogens or heavily chlorinated. And also, because that's really expensive and difficult, we're only going to do that to about 40% of the human waste, and the rest of it, we're just going to let it just swill around where everybody is, just around everyone's knees, and make them really sick. So I'm going to say that's quite a hard sell as a policy position. But it's not even just that bad. In addition to that, separately, we're going to grow crops to feed ourselves. In order to do that, we're going to invest in a massive industrial complex to produce more than enough industrial fertilizers to fertilize those crops, also at high cost, also resulting in huge emissions. We're then going to ship those all around the world at very high cost. And we're going to apply them to our farmland, which is going to result in irreversible damage to the soil and additional human health risks. Hurrah. So now we've massively increased emissions, massively created pollution, made a whole bunch of people really sick, and catastrophically destroyed our soil chemistry. So it's sort of odd, isn't it, that the circular economy idea is such a hard sell. So I was trying to think, why is this such a difficult conversation? I mean, all of us in this room, we know this is possible. We know it's a smart thing to do. We know it's not the whole answer, but we know it's a big part of the answer. So the interesting question is, why is our positive story so difficult to sell to policymakers and to practitioners? And I think one of the things is that the status quo it's simple because everybody's just doing the job they've always done. It's familiar. It's also incredibly insular and siloized. We have very, very high levels of specialization in the sector now. So we have people who are supremely expert in the tertiary step of a conventional wastewater treatment process that is widely used in southern Germany. And that person doesn't see a role for themselves in a new, modified, sort of more adaptive circular economy. I also think an elephant in the room for me is that there are a lot of very powerful incentives at play in the current system. There's a lot of money in chemical fertilizer manufacture, and there are a lot of governments who have very, very big political stake in maintaining, for example, high levels of subsidy to the farming community. And at the moment, a lot of that is delivered through subsidized sale of chemical fertilizers. And even if those governments are willing to make changes, changing that is extremely politically difficult. It's also technically a bit difficult, but it's mostly politics. So I can understand why we're finding it difficult to make this transformative change. We've got people that are so highly skilled that they can't see a role for themselves in the new status quo. And we've got a bunch of fixed incentives, plus we've got a whole load of set sunk investments in infrastructure. So the challenge, if we're going to sort of transform this thing, the challenge is that we now know, and we heard from our colleagues at the beginning, that we need to make transformation which is locally appropriate, contextually specific, and it's going to be different. The sort of thing that Stuart Kirk is designing for West Yorkshire in the UK is not the same sort of thing as our colleagues in China are designing for Northwest China. So we've got to think about how can we equip people with the skills and the knowledge, not just to apply some sort of blanket standard methodology, but to actually be able to design these nexus systems that link human waste, improving sanitation, making wastewater treatment efficient and appropriate, and linking it into the local agricultural economy. The sorts of things that Jeremy touched on ever so briefly, but are super important. In one place, manufacturing struvite might be the best option. In another place, encouraging people to use the contents of their pit latrine locally in a market garden might be the best solution. So how do we equip people locally with the skills to do that? The other thing I think that's really important is we mustn't try and fix this but by just adding additional steps to an already imperfect system. We had a brief conversation in our group about this. You know, the temptation to sort of solve the problem by adding more to what we already have, I think would be a grave mistake, because the systems we already have are incredibly inefficient, in my opinion. So I do think we need to work out how can we work, for example, if we're worried about pharmaceutical application through human waste reuse, let's not just put in additional treatment steps to remove those pharmaceuticals. Let's go back to the source and say, why are there pharmaceuticals in the human waste stream to start with? Is there something we can do systemically to improve that? I think that's super important. I want to also say one thing myself, and this is based on a lot of work that I've done with water companies over the years and sanitation providers, trying to think about how they can be encouraged to provide services to the very poorest. And one thing I think I've learned myself is that people respond much more to positive incentives than to negative regulatory barriers. So one thing we must also do is really try and think, and I think in our group we heard some fantastic examples, particularly from China, of ways in which you can make it more easy and more attractive to do the right thing than to stick with the status quo. We've really got to think about how can we make it the easiest thing for people to do the right thing rather than the wrong thing. Just glancing through the groups, I wanted to just touch on a couple of things. A theme which has come up quite a lot is definitely this idea of that we have two very different types of systems. We have centralized, what we might think of as networked urban systems, and we have more decentralized, often more rural systems. Patrick, I can see there's a couple of comments in your group on this. I don't know if you want to, I don't know, speak for your group, or if somebody from group 2 wanted to just touch on this whole idea of scale and whether we have very different approaches at different scales.
Yeah, I mean, Jeremy mentioned that there's a lot of potential for resource recovery from decentralized systems in China. And this is largely because, first of all, they don't suffer a lot of this industrial pollution that many of the centralized systems have, and also because they're very closely located to the surrounding agriculture, more so than the US, where it tends to be a much bigger gap between cities and agriculture. There's more potential to use waste there because it doesn't really require the same degree of treatment, and because it doesn't require the same degree of transport.
Oh, super interesting. Yeah, no. So, but then I suppose what's interesting to me about that is that then you've got to work out how to make that happen at the local level, which is quite challenging because then you've got a very diverse group of actors engaged in that process, right?
Yeah, because there's a lot of human safety concerns as well, and working with human waste as well. Yeah. I think Jeremy's probably more qualified to talk about that than I am. I'm just writing up his notes as I speak.
I have to say, top marks for you, Patrick. You've won the prize for putting notes in the Padlet.
Right, there are more coming, I promise. Yeah, I'm new to Padlet, but I have them written down. I did it the slow way first.
The old-fashioned way. The other thing I just wanted to draw on was certainly from group 1 where I was listening in. I don't know if I could ask, who was I going to ask? Maybe Su Yongguan. This question of creating positive incentives in policy. I don't know if you just want to say a couple of words about that. I thought it was very interesting.
Yeah. So in China, in some places, the government subsidize organic fertilizer. So I would say 1/3 of the cost that can be covered by the government, which is really a very good policy to replace part of the chemical fertilizers and also improve the soil fertility by using more organic fertilizers.
Yeah, thank you. So again, this idea of creating, and that's something that we can do quite centrally. It's quite a sort of simple unilateral lever, but which can create behavioral incentives amongst a huge group of people who can then make localized decisions, but using that reduced cost as the way to, especially when you're trying to get people to switch from one mode of operating to another mode of operating. I just want to ask if there's anybody from group 3 who picked up, I don't have any notes for group 3, so I don't know if there's just a point that maybe somebody in group 3 might like to add to what we've already discussed. Chen looks like he's about to lean forward with great enthusiasm.
Thank you. I think John has our notes, and maybe John can say something and I can add something. John, can you hear us?
Hello. Yep. Sorry. It was an interesting discussion, and I'm just currently writing it down. There's a lot of information, but I'll give you the brief overview. So there are current policies and frameworks in place to protect the environment from both emerging and existing contaminants. These exist within both UK and China, although further development is required due to the complex nature of the system. We briefly went over the Zero Action Plan, so reduction in pesticide and fertilizer usage within China. So 0% increases the requirement in order to protect the environment. And we then went on to talk about the UK and EU legislation to protect the environment from both organic and inorganic contaminants. So these are things like what the Framework Directive or the Nitrate Directive, and whether these legislations are followed are given, and the practicalities at farm scale is hard to judge or even control. So it's something important to consider, given, for example, practicalities of storing and applying waste is often not, so the legislations don't meet farm requirements and the practicalities that the farmer themselves would face. Moving on, in order to improve current policies and further our development, we need to integrate the waste sector and the agricultural sector. So this will also bring around collaborative thinking, combined concerns, and also additional funding if the sectors are linked up. And I think that's a really important point that we made. And so further on, the issues we face are not new, and the issues we are against are the same for both human and agricultural waste for fertilizer usage. These are issues with heavy metals such as lead, cadmium, and the buildup of these within the soils or repeat application of organic fertilizer. So the emerging contaminants of concern, pharmaceuticals, surfactants, and other domestic products. We need to consider these issues in both the aquatic and terrestrial. We need to consider these issues for both the aquatic and terrestrial organisms. We briefly, which we will go on in the section 2 and 3, need to consider the risks from both industry and domestic. Moreover, whether the mixture effect of these contaminants has been investigated. So, for example, metals and pharmaceuticals. I think the final point is current legislations and policies only assess the toxicology of single contaminants, and more work is required, but it's a realistic and environmental level. And I guess the take-home message we had was we need to link the sectors together to address these issues and identify the primary drivers and concerns in order to improve current policy and future policy drivers.
Yeah, thanks. I think this linkage challenge, which is not trivial, we can say it as much as we like, oh, we should all collaborate together, but it's really not super easy. Chen, did you have a very brief point? And then I'm going to give Tim the floor very briefly.
Okay, thank you. I think in terms of, from our discussion, in terms of the circular economy, if we think about the whole circle from waste to soil, to agriculture, to people, and to economy, and these are different components. So therefore, integrating thinking is critical to, for the future thinking for this problem. And the integrating thinking is not just for the methods, combined multidisciplinary research, but also for the policy making, because we have different type of policy falling in different sects. And for risks assessment, because mixture of risks may amplify the risks. And also for the technical side. So that is our conclusion. And that is why it is a bit harder to sell this idea, as Barbara mentioned, because we need integrated thinking. And that is why this conference is so important to bring us all together. Thank you.
Thanks, Tim. That's really helpful. Tim, I spotted your hand earlier. Did you want to come in? You're muted.
You think I would have learned about that after a year? So yeah, it's just really something that Ying Zhang from Dongbei brought up right at the end of our conversation about the need not to forget that we need to also have a focus on how we apply fertilizers, how we formulate the different fertilizers, crop requirements, how all of the agronomy, breeding even, might need to change as we shift to a more circular system, because we're completely changing the way that we drive production, and that's likely to have different requirements agriculturally. That was all I wanted to add, just to make sure we didn't lose that.
Yeah, very helpful. Stuart, you've got 20 seconds.
Okay. We're getting on to discussion quite rightly about barriers to big changes, and I just wanted to throw in that in all areas that's similar to this, it's recognized that we really do need to bring in social scientists and humanities much more into understanding how we do get the change, and that does include economists as well. So if you really are looking at understanding the barriers and opportunities, we need to make sure it's not a technocratic approach we're going for alone.
Stuart, you're so kind. Stuart doesn't know this, but my second degree is in economics. So I'm always happy when people say, yeah, we need an economist as well. So thanks very much to everybody for that incredibly rich discussion. Obviously, we will capture the notes and write that all up. It's impossible in 20 minutes to sum it up. But if I could think of 3 things that I think are great and really positive coming out of this. One is, we should be fighting an easy battle because we are challenging a system which is in itself deeply, deeply flawed, and we should not forget that. What our systems or our propositions can do can be compared not only against a baseline, but also against what we're replacing, which is itself extremely faulty and has a great number of, is creating a lot of problems that we need to solve. And I think the second thing is definitely this theme of collaboration. But also, I would like to say it's very exciting to be in a room with people with incredibly deep specialist knowledge. And we do need to find ways of blending those two things. So, I don't want, as a public health engineer, to be in the room trying to decide how to do fertilizer application. So I think this sort of whole idea of creating T-shaped teams where we have lots of deep specialization, but we're linking it across sectors, is something that this group's really exemplifying, and it's very exciting. And that brings me very nicely to the next piece of the agenda, which is to ask Laura, where do we go with all of this incredibly rich discussion? Laura, you're muted, sorry.
I can't believe that. So no, I was just saying that I'd like to echo some of the points that have just been made about the discussions that we've had. I think it's been really enjoyable this morning hearing this concept, but coming at it from a number of different viewpoints. So as Barbara mentioned, we're going to be talking about next steps now. So hopefully you're all aware that this dialogue is part of the UN Food Systems Summit, and they would like us to report back to them with the main findings that have emerged from our discussions. So this includes thinking about connections between stakeholders, an agreement on some key knowledge gaps, and then potentially thinking about how we need to carry out research and which aspects we really need to focus on in depth going forwards. So for this, we are constrained by the reporting template here that the UN Food Systems Summit have provided us, but our plan is to collate all of the notes that have been taken. So in the various breakout sessions, as well as the summary discussion that we've just had. And then we're going to create this report. And then in the first instance, we're going to circulate this to the discussion group leaders and the note takers. And then we're going to circulate this to the wider group for comments. And it's, I think, a really good position that we're in, because all of the individual reports will be able to inform the summit process, and they're going to be made publicly available. So we really have an opportunity to put forward our viewpoints on this. And then building on this report, our next steps would be to create a policy brief on this topic, which synthesizes all of the key discussion points. And this will give us a little more scope to elaborate further than what we have to report to the UN Food Systems Summit. And obviously all participants in this session will have the opportunity to be involved in this and to be a co-author on this policy brief. But I think ultimately our aim is to draw on all of these collective viewpoints to present an authoritative piece, an opinion piece on the topic of using sustainable agricultural systems and the reuse of materials from sanitation waste streams. So this will be a position paper in a high impact journal. And again, we're going to welcome input from all of the participants towards this, but we would require you to be responsive and to contribute to the production of this final output. So hopefully this is an exciting opportunity for everybody, but I think we have the makings of a really strong paper here to build on the discussions that we've had. So in the meantime, I'd like to draw your attention to a Padlet wall that we've created. So this is to ensure everybody has the opportunity to contribute to this discussion. So I know the breakout groups were quite fast paced, and I think we actually got transported back into this room midway through a conversation. So the idea of the Padlet wall is to get everybody to contribute some discussion points that perhaps they weren't able to put forward in their group discussions. So you could do this through a video or a short presentation or some short summary text. So the Padlet will really enable you to contribute in any way that you would like to. But it would be great to get your interests and how you see your work fitting in this space. So I think Sarah's going to share a link to this Padlet wall in the chat for this Zoom call. And this will outline how you can contribute and what kind of things you can add to the Padlet wall. So I will just finish there to say that we will be continuing to work on this in the coming months. And I'm excited to share with you the first outputs that we can create. So thank you very much for your contribution. And I'll hand over to Steve for a final wrap up.
Great, thank you. I'll be brief to let people get on with their lives. Just a huge thank you to everyone for participating today. Barbara, thank you for really leading a fantastic final session. Your opening statement is clearly going to be the first paragraph of the authoritative position paper. And I would really look forward to hearing that live from the platform during the World Food Summit. I think it was just a fantastic piece of science communication for policy. Thank you for a great wrap-up session. Just a comment to the overall participation. You know, many of us here have worked together over the last 3 to 4 years for the China-UK Critical Zone Observatory program exactly on this topic. It's very bittersweet. It's great that we could come together today to work. Normally, we are getting together in person a couple of times a year, either in Europe or in China. And it's just wonderful to see so many friends and colleagues from that project. And I'm also just very grateful for everybody, all of our participants, Stuart, Jeremy, Anna, many others who joined, who have not been explicitly embedded in that particular project. Thank you, everybody, for joining in the group today and contributing your expertise, your knowledge, your participation. I'll look forward to working with everybody on the next steps, working together with all of you as co-authors to produce some strong outputs. And it remains to thank Laura and Sarah, my co-conveners of this event. Also Victoria Samir, our communications officer for the Global Food and Environment Institute, and Penny Andrews, administrator for the Institute, for helping with all the organization, both before and after, including communications output from us. Sarah, did I miss anybody on the thanks?
No, I think you've covered everybody.
Okay, great. With that then, thank you everybody, from those of you who joined us from the middle of the night to those of you who joined us from the East Coast of East Asia. That's been fantastic. I see the potential for further meetings and broaden our discussions. I see this northern sort of East Asia, European, America, but with a global South deeply engaging with our colleagues and projects in sub-Saharan Africa. I think this is that's a potential group that we could pick up the discussion much more completely and much more fully in a future event or events. So hold that thought and think about how we might move towards that over the coming year, and hopefully virus variants don't get too out of control, and we can within our countries and within our collaborating regions around the world move to a safer life over the coming 12 months. So with that, just thank you everyone, and look forward to keeping in touch and working with you. And I'm really, really proud of what we're going to report back to the UN Food Summit Organizing Committee. I'm very curious. I don't know what will become of these reports. There are many, many of these dialogues taking place now through the end of May. So we will make sure that this doesn't disappear into intergovernmental bureaucracy, but we will ensure that we make use of the hard work that everybody did today. Thank you, everybody, and goodbye.